Hello and welcome to this second algebra lesson of Unit 1. My name is Melissa Lieberman and I'm your teacher for today. If you want to contact me at any time during your time with ICS Learn, my contact details are there. You can phone me direct or email me mathsteacher@icslearn.co.uk. So in this lesson, we've met some basics of algebra last time, and today I'm going to introduce you to equations, formulae, and inequalities. Now, this is really just intended as an introduction to these three types of algebraic objects. I'm not going to go into very great detail about how to solve them because we'll go into that. We'll revisit these later on and throughout your course material. So if you've not done a lot of algebra before, just do your best with these and we'll have the opportunity to revisit them later on. Just a moment, there's someone who can't hear me, I'm just going to sort this out. So as always, this lesson will last about 1 hour, sometimes I do go over a little bit, and the session will be recorded so that you can watch it back as many times as you want. For example, if you prefer to break it down into smaller chunks, you can just watch it bit by bit and pause whenever you want to by watching the recording. Of course, you can't pause if you're watching live, but you can watch it back later on as many times as you need to throughout your support period. Now, if you are watching this lesson, I would always encourage you to write everything down, and I always say that, but that will just help you to have something to revise from later on so that you don't have to go through the webinar again. If you're watching the password protected stream version of this session, I mean, actually at the moment you don't need a password anymore, but if you open this up in WebEx, then it's the high resolution WebEx version that you're watching. Make sure that you have the chat panel turned on, so make sure that you go to the top of the page right now, press view, and then open up chat panel. That's only if you're watching the recorded version. I'll also point out here that if you're watching the WebEx version and you don't want to watch the video, you can just turn off the video, press a little X at the top, and then just go through the slides using the table of contents. So you don't need to watch the video. If you would rather just go through the slides at your own pace and make notes using the slides, that's absolutely fine. If you are having trouble running WebEx, use WebEx if you can, but if you're having trouble using WebEx and you're watching the YouTube version, it's not so good resolution and the links won't be working in the chat box. To find the links, you'll need to go to the box under the video where it says show more at the bottom in capital letters. Click on that and this will give you a drop down menu with all of the links in it so that you can use the links which I'm pasting into the chat box as I go through. So first of all, I'm going to talk about, I know we've met expressions already, we did that last lesson, but I'm just going to talk about the difference between an expression, an equation, a formula, and an inequality. We're going to look at how to solve a few basic types of equations. I'm not going to go into any great detail, just the real basics of how to go about solving an equation. I'm going to introduce you to formulae and how we go about substituting values into formulae. So we met substitution briefly last lesson, so please make sure you watch that if you haven't already. And I'll show you how to substitute values into formulae in maths. We'll have a quick look at how to write formulae, given some basic information. And then lastly, we'll have a quick look at inequalities and how to understand how inequality symbols work. Sometimes they're called inequations. You may have met them before and not known that they were called inequalities. It's expressions that have greater than or less than symbols in, so we'll talk about that at the end. So first of all, let's talk about the difference between these four things that you find a lot in algebra. So first of all, we've got an expression, and we talked about that last time. It's like a sentence in algebra. It gives you some information, but not enough information to find out what the letter symbols have, what the value of the letter symbols are. So letter symbols, remember, in algebra are just used to represent any number. So if you've got something like 2a, it just means 2 times a number where a is any number. And if there's no equal sign, then that means it's just an expression. So for example, if you have something like 3a plus b minus 7c, that means 3 times a number a, just any number, plus a number b, subtract 7 times a number c. So we don't need to know the values of a, b, and c, it's just an expression. Now, these letters are variables, which means that they can take on any value. Then we have an equation. Now, an equation kind of links two expressions with an equal sign. So sometimes it's just something equal to a number, but sometimes it's two expressions with an equal sign between it. Now, the difference between an expression and equation is that we can solve an equation. When we talk about solving an equation, what we mean is finding the value of the letter that makes that equation true. So here's an example. Maybe you can already think of a way to solve this equation. What it says is 2 times a number x plus 5 equals 13. So this is a little bit like saying, right, I'm thinking of a number. You don't know what it is. You have to find it. If I double that number and add 5 to it, then the answer is 13. So what we have to do is kind of undo what's been done to that number. So when we're solving equations, when we're trying to find the value of the letter, there's a lot of kind of undoing operations. So you need to think a lot about what's the opposite of adding, what's the opposite of multiplying, and you do them in the other order. So if I double a number and add 5 to it, the way I undo what's been done to it is I subtract 5 and half it. So if I start with 13, which is what I ended up with, subtract 5, so 13, take away 5 is 8, and then half that, we get 4. And then always check whether that works. Well, double 4 and I get 8, and add 5 and I get 13. Another way you could do it is just scrub this out and just say to yourself, well, what do I add to 5 to get 13? Well, I know that 8 plus 5 is 13, so that 2x must be equal to 8. And if double x is equal to 8, then x must be 4, because double 4 is equal to 8. So we can use this kind of systematic way to solve equations. Now, equations can be much more complicated than this. I know they can have lots of x's in, they can have fractions in, all sorts of things. But today we'll just stick to the basics of the strategy that we use to solve equations. Ahmed, yes, start by taking away 5 on both sides. And the answer is x equal to 4. So everyone that's written that down, perfect, well done. You've already got the hang of basic equations. You don't need to watch this lesson anymore. You can go home. Don't worry, I think you should still watch it because I'll just go through it all again. So the letters represent unknown values which we can find the value of. With a simple equation like this, x just has one value. There's only one possible value for x that can solve this equation. But sometimes it can have more than one value. For example, when we do quadratic equations later on, and quadratic equations are now at foundations here, so you're all going to do quadratic equations at some point. In that case, the x can take more than one value. It can take 2 values, for example. Okay, now a formula is a little bit different. A formula is a rule that helps you work something out. So you all met formulae before. For example, the area of a rectangle is the length times the breadth. So A area equals LB, length times breadth, for example. Or you might have used a formula to convert Fahrenheit to centigrade or that sort of thing. So formulae come up a lot, and the first way to spot them is that they'll have more than one letter in them. So they'll usually have a few letters in them. You can't just have one because it's to link different physical amounts. And also formulae almost always start, and if they don't, then you'll need to rearrange them so that they do with just a letter, a single letter on the left-hand side. So it'll be something like A equals, B equals, C equals, and then some kind of expression that links together the other letters in the formula. Now, you have to be a little bit careful with formulae because the letters stand for physical quantities, and that means that often they'll have units in them. So the one thing I'd like to point out about a formulae is that when you put the numbers into the formulae, just put the numbers and not the units. You have to make sure everything's in the right units first so that you get the right values out the other side. But obviously we'll meet formulae a lot during this course, but just today we're going to be just introducing the basics. And then lastly, an inequality is like an equation, but it has greater than or equal to. Hopefully you've met these signs before. So this sign means greater than. This sign means greater than or equal to. So the little line underneath the symbol means greater than or equal to. This means less than, and this means less than or equal to. And for these examples, the solution will have a range of values. So the letter symbol will be every value less than 5, for example. So we have a whole range of values. And later on in this lesson, I'll show you how to show a range of values on a number line. So for example, if I had that n, which just stands for a number, plus 3 is greater than or equal to 7, any idea what value n could be? Well, for example, if n was 10, I would have 10 plus 3, which is 13. So that would be right. That would work for that inequality. What if n was 5? Then I would have 5 plus 3, which is 8. That would work. How about if n was 4? Then I would have 4 plus 3, which is 7. That is equal to 7, so that would work. So anything bigger. So if n is bigger than I've forgotten what I've forgotten what I said then. If n is 4 or more, then it will solve this inequality. So in this inequality, there's a range of values because n can be any number bigger than 4. Because any number bigger than 4 will make this statement true. So in an inequality, you've got a range of solutions, but you solve it in a very similar way to an equation. And I'll go through the steps later on. If not in this lesson, we'll do it another time. So it's a range of values. Okay then. Let's have a look at solving equations first. Now I've put linear equations. Don't worry too much right now what that means. Basically, it just means that the letters don't have any powers in them. So they don't have squares or cubes or dividing by the letter. And that's a linear equation. If I plotted it on a graph, it would make a straight line. So linear comes from the word line. So solving an equation just means finding the value of the letter that makes both sides equal, that makes it balanced, that makes the statement true, in other words. You can think of it as a pair of scales like that. I just took that picture from the textbook. So the way we normally think of an equation is whatever we do to the left-hand side, we do the same thing to the right-hand side. So if you add 2 to the left, you've got to add 2 to the right so that it still is equal in balance. And this is the best way to solve equations. There are other ways. So for example, some people will say change the side and change the sign. And I think there are some examples like that in your course notes. When you're just starting, you might find it easier to think of it that way, but it will cause problems later on when you do more complex equations. So the best way to do it right from the start is to always do the same thing to both sides until you've got the equation in the form that you want. And usually that will be with the letter on the left-hand side on its own with no numbers attached to it and a number on the right-hand side, and that will be your solution or the answer to that equation. So let's have a look at a few examples. So here's a slightly more complex example because 2 things have been done to this letter A. If you had something like 3a plus 2 equals 14, you've got 3 times a number. So it's a little bit like the problem I said earlier. I think of a number, multiply it by 3, add 2, and the answer is 14. So you can either think of it as reverse operations or undoing. You can start with 14, subtract 2 to get 12, divide by 3 to get 4. All of these seem to have 4 as the answer. It's not intentional. So you can either do it that way, or you can do the same thing to both sides. So subtract 2 from both sides. 14, take away 2 is 12, and then divide by 3. And that will get the A on its own on the left, and it will get the answer 4 on the right. And then always to check that that makes sense, check that it does make that expression true, put the 4 back into the original equation. So make sure that 3, remember this means 3a means 3 times a. So 3 times 4 is 12, plus 2 is 14. So yes, that does work. And then that side is 14, obviously, because it's just 14. So both sides are equal to 14. Okay, so this is how you must set it out. 3a plus 2 equals 14. Always write the next step in your working underneath and line up the equal sign. But first what I'm going to now this bit that I'm writing in blue, you don't have to write it down. You can just do it in your head. But I'm just going to write it down to show what I'm doing. So the first step is to subtract 2 from both sides. And the reason I'm subtracting 2 from both sides first is because I'm trying to get the a on its own. So the object is to get a on its own on this side and to get the number, just any, whatever the answer is, number on this side. So I'm just going to try step by step to undo what's been done to the a. So I don't want this plus 2 here. I want to get rid of that. The best way to get rid of plus 2 is to subtract 2. So if I subtract 2 from the left-hand side, I need to also subtract 2 from the right-hand side to keep the balance. So put those in, or do it in your head. So on the left-hand side, I will have 3a, and on the right-hand side, I will have 12. Write that underneath and line up the equal signs. Now if I know that 3a, or 3 times a, is 12, then I need to divide by 3 to get the final answer. So I'm going to divide both sides by 3 to find out what a is equal to. So if I divide the left-hand side of the equal sign by 3, then I need to just divide whatever is on the right-hand side of the equal sign by 3. So divide both sides of the equal sign by 3. I'm just going to put the divide by 3 like that underneath. It's a bit neater than putting divide by. 3a divided by 3 is just a, which is what I wanted, which is why I divided by 3. And then 12 divided by 3 is 4. So write it like that. Make sure that you write each bit on a separate line and line up the equal signs like that. Okay, you always have to set equations out in this way. Let's have a look at a couple more examples. So we'll start with some really simple ones. Solve the following equations. Now you can probably do these ones in your head, but I just want you to set them out in the proper way that we do in algebra. If you can do it in your head, fair enough. But the reason you need to learn the method is that equations are going to be much more difficult as you work through the course. So it's good to get into the habit of doing it in the right way. Now, for part A, it's quite straightforward. We've just got x, which is the number we're trying to find, plus 3 is equal to 10. So we've got a few people answering x equals 7. Of course it is. It's very easy. 7 plus 3 equals 10, so x must be 7. But how do we do it algebraically? So what we need to do it algebraically is we need to subtract 3 from both sides. So we're trying to get rid of this plus 3. So to get rid of that plus 3, we need to take away 3 from the left-hand side of the equal sign. And so we need to take away 3 from this side like that. So this is how we set it out. Take away 3 from both sides. X plus 3 take away 3 is just x because we've subtracted the 3's, and then 10 take away 3 is 7. So we just do it like that. Take away 3 from both sides, we get x equals 7, that's the answer. And to check it, just put the 7 back into the equation. 7 plus 3 is 10, so we know that we're right. Now about part B. This should be quite straightforward. This time we're taking away 5 from the y. So if we're subtracting 5, to get rid of the subtract 5, we need to add 5. So we need to add 5 to both sides to find the answer. Does that make sense? You probably could do it in your head, but let's have a look. So y subtract 5 plus 5 is just y, because minus 5 plus 5 is nothing. And then if we add 5 to the left-hand side, we have to add 5 to the right-hand side. 4 plus 5 is 9. The answer is 9. I know you probably could have done it in your head, but I just want you to get used to doing it in this more algebraic way. Check that your answer is true by substituting it back into the original equation. 9 take away 5 is 4. So that's right. Okay, so ones with pluses and minuses, that's how we deal with them. Sometimes they've got multiplication and division in them. So here's a few, one with a multiplication in it. Remember, 4t just means 4 multiplied by t, 4 times t. And part B, r divided by 5 is 3. Okay, let's have a think about these. So for part A, 4 multiplied by this number t is equal to 32. So to get the t on its own, I need to divide by 4. So I'm going to divide both sides by 4. If I divide the left-hand side by 4 to get the t on its own, I need to divide the right-hand side by 4 so that it's still equal. So divide both sides by 4. So on the left-hand side, I have t on its own, which is what I wanted. And then 32 divided by 4 is 8. Always line up the equal signs. And then make sure that that answer is right. 4 times 8 is 32. So t is 8 because that's the number I was looking for, and that makes my statement correct. How about part B? So everyone that put t equals 8 is right, Sidra and Rob. Good. Now, a lot of people struggle with equations, so I'm not assuming that this is easy by any means. I think it's really important, though, right at the beginning, to set these out in the right way. So what part B is saying to us is that this number that we're trying to find, r, divided by 5, is equal to 3. So what number divided by 5 is equal to 3? Well, the way that I work that out is to multiply both sides by 5. So it's a little bit like cancelling. If I multiply the left-hand side by 5, I put a 5 there, and then I multiply the right-hand side by 5, I put the 5 there. It's still, because I've done the same thing to both sides, it's still equal. But then these cancel. So the 5 on the top cancels with the 5 at the bottom, so I get r on its own, which is what I wanted. So multiplying both sides by 5, sorry, the 5's cancel, r's on its own, and then I've got 3 times 5 on the right. So r is equal to 15, and then check that that works. 15 divided by 5 is 3, so that's correct. I've got the right answer, so I know that I've done it the way that I should. So Bernice and Violet and Rob and Sidra, good. If you can do it in your head and just write the answer directly on the next line, that's fine. But just have a think about doing this method of doing the same thing to both sides so that it will help you later on. Now, here's a two-step equation. By two-step, I just mean that I've multiplied the letter by something and I've taken something away, so we'll need to do more than one step to get the answer. So how do I sort this out? Now I can see that I've got 8w here. So maybe I could divide everything by 8. That wouldn't quite work though. I mean, I could divide this by 8, and I could divide this by 8. But then I'd also have to divide this by 8 because everything in the equation would have to be divided by 8. And it would be a big mess because I'd have to work out -5 divided by 8 and 11 divided by 8. And I'd have the W on its own, but then the rest would be some very difficult arithmetic. So rather than do divide by 8 on the first step, I do divide by 8 in the second step. What I would advise with this one is to sort out the -5 first. To get rid of the -5, I need to add 5. So I'm going to start by adding 5 to both sides. So that's the first thing, that you're the one that's deciding what you're going to do to both sides. And you say, how do I get this W on its own? How do I get this W on its own? Well, I need to get rid of the 5. It's -5, so I need to add 5. I need to get rid of the 8. It's multiplied by 8, so I'm going to need to divide by 8. So in 2 steps, you're going to add 5 to both sides, and you're going to divide both sides by 8. Let's see how that works out. So first of all, add 5 to both sides. That will give me 8W on the left of the equal sign, and it will give me 16 on the right, like that. Good. First, I'm just reading what Cidra's written. First, add 5 on both sides, then divide by 8. That's perfect. Good. So 8W is equal to 16. Now it's quite easy because all this is telling me is that 8 multiplied by the number is equal to 16. So 8 times what equals 16? Well, 8 times 2 is equal to 16, or just do 16 divided by 8. So if we divide both sides by 8, the W will be on its own because the 8's cancel out, and then 16 divided by 8 is 2. Substitute that back into the original equation to make sure that works. 8 times 2 is 16, and 16 subtract 5 is 11, so it works. Okay, good. How about this one? Now this time we've got k, this number we're trying to find, divided by 4, plus 1 equals 6. So first of all, we're going to try and get rid of this plus 1, because remember we just want k on its own. So to get rid of that plus 1, we're going to subtract 1 from both sides of the equation. That's how we undo adding 1. It's the inverse operation. So start by taking away 1 from both sides. If we subtract 1 from both sides, we've got k over 4. These just become 0, because that's what we wanted, is to get 0 there. And then 5 take away, sorry, I said the answer. 6 take away 1 is 5. So we've got k over 4 equals 5. How are we going to get k on its own now? So we've got k divided by 4 equals 5. So we need to multiply by 4 to get rid of the divide by 4 on the left-hand side. So we're going to multiply both sides by 4, like that. Those 4's will then cancel out so that I get k on its own. And then on the right-hand side, sorry, I've got 5 times 4. So multiply both sides by 4. These cancel out, as I said, like that. It's got k on its own, and the answer will be, or the solution to this equation will be 25 times 4 is 20. Check that that works, so put it back into the original equation. That would give me 20 divided by 4, which is 5, plus 1 equals 6. Good, so that works. Okay, how about this one? Now this time we've got h plus 8 divided by 3, and the h plus 8 is above the fraction, so I can't really take away 8 from both sides to start this off because the 8 is also being divided by 3. So it's like, because of the order that it's been done in, we'll need to unpick it in a different way. So we'll need to get rid of the divide by 3 first. How do I get rid of the divide by 3? How do I undo divide by 3? What shall I do to both sides first? Answers in the chat box, please. Sidra multiplied by 3, Ahmed times 3. Does everyone agree? Yeah, good. We're going to multiply both sides by 3. So this h, if I ever said, right, I think of a number, I add 8 to it, and then I divide by 3. So because I've divided by 3 at the end, I need to start with that. So I need to multiply by 3 and then subtract the 8 to get to kind of undo what's been done to the number. So multiply both sides by 3, and that gets rid of the 3 on the bottom. It cancels it out. So on the left-hand side of the equal sign, I have h plus 8. On the right-hand side of the equal sign, I have 2 times 3, which is 6. Let's write that down first. h plus 8 equals 6. And then I need to get the h on its own. I don't want h plus 8, so I need to get rid of the plus 8. So I need to subtract 8 from both sides. Remember, if I subtract 8 from the left, I also have to subtract 8 from the right. We're on the right-hand side of the equal sign, so let's subtract 8 from both sides like that. That will give me the h on its own on the left-hand side, which is what I wanted. And then I've got 6 subtract 8. Very good, everyone that's written -2 there. Good. 6 take away 8 is -2. So h is equal to -2. And then check that that works. So if I put that back into my original equation, I've got -2, -2, plus 8, which is the same as 8 take away 2, which is 6, divided by 3. 6 divided by 3 is 2. So that's right. Okay. There we go. If you put it back into the original equation, I've just written it like this all in one line, so you can check it quickly. Okay with that? Okay. One more. Can't remember. Maybe there is one more. Maybe there are a few more, but I think we'll just stop soon. Okay. 3n, where n is just the number that we're trying to find, divided by 5 equals 6. How should we get rid of the 3 on the top and the 5 on the bottom? You can kind of do it in one step, but let's do it in 2. So as soon as you see a fraction, a number on the bottom, then you need to get rid of that. And you get rid of that by multiplying everything in the equation by the number that's on the bottom. So we're going to multiply everything by 5, and that will get rid of the fraction on the bottom. If I times the top by 5, then the 5s will cancel. And if I multiply this by 5, I get 30. So let's put that in. Multiply both sides by 5. 5's cancel, so I'll be just left with the 3n. And then 6 times 5 is 30. So 3n equals 30. 3 times n equals 30 to get rid of the times 3, which is what that 3 in front of the n is doing, it's multiplying. We divide by 3 both sides. So if 3n's are 30, then 1n, or just n on its own, will be 10. So we just divide both sides by 3. So n equals 10. Let's check that that works. 3 times 10. 3 times 10 is 30 divided by 5. And 30 divided by 5 is 6. So that's right. Okay, 30 divided by 10 divided by 3. Okay, good. Good. Okay, here's another one now. This one is a little bit more difficult because we've got the 70 in the second part of the equation. So we might have some negative numbers. We can have negative numbers. We can have fractions. That's absolutely fine. Don't worry about that. It can happen in algebra as long as you follow the steps. The solution will be right. So let's have a look at this example. Ahmed, yes, take away 7 from both sides. So we're trying to get e on its own. So the first step will be to subtract 11 from both sides. So we'll do that first. So take away 11 from both sides. So 7e. Take away 11, we'll just leave with 7e on the left, and 9 take away 11, it's going to give me a negative number, -2, like that. How do I get e on its own? Well, I just divide both sides by 7. 7e divided by 7 is just e, which is what I wanted, and -2 divided by 7 is just -2 over 7. So really don't panic if you end up with fractions, just write it as a fraction and that's the answer, and that's completely fine, just leave it like that. If the top number is bigger than the bottom number, you might want to convert it into a mixed number, but you don't have to. You just leave it like that. And if you can cancel it down, cancel it down. So that's how it works when the number doesn't divide exactly in there. That's exactly right. Lisa, can you swap the numbers around 7e before 11? Yeah, you can. You can write this as 7e plus 11 equals 9 if you think it doesn't really make any difference. I was trying to think of a situation where I might do that if there was a negative number, maybe. But you can do that. Another thing that you can do in algebra is swap the sides. So you could write it as 9. In some situations, not in this particular example, but if you wanted to write it as 9 equals 11 plus 7e, that means exactly the same thing. So one thing you can do in an equation is swap the sides around. That's just another rule of equations. It won't. Sometimes it helps to swap the sides if you've got a negative number or something like that, but I'm not going to go through any complicated examples at the moment. I think the main thing with equations is just do as many examples as you can. You just need to do loads and loads and loads and loads of examples until it just becomes instant. It will just take a little practice if you've not done it before. Okay, so e is -7 over 2. I'm going to give you a link to some videos. Now, we're going to revisit this, don't worry. I'm really just giving you a very basic introduction at the moment. And just do as many examples as you can. If you've not done it before, you're finding it hard, don't spend too long on it. Don't worry about the swapping the sides, it's not really important. Remember just to go through the steps. I've also included in here a video on solving equations with the x on both sides. I've not done any examples of that today, but have a look at this video clip if you have time and if you want to try some of those examples. If the other ones are quite easy for you and you want to push yourself a little further, then do that. Everyone is going to find it, you know, it's a different place. Some people find it really easy, some people find it really hard. Don't panic if you're finding it difficult. You can always go back to it later on, and I will revisit more difficult examples later on. Okay, let's have a quick look at formulae. Also I was going to give you these interactive worksheets might be useful. If you go, this is CIMT, which stands for the Centre for Innovation in Mathematics Teaching. You've got some interactive worksheets there, so you might want to go through. There's little boxes, you can type in your numbers, press check, and it tells you whether you're right or not. So if you want to have some extra exercises to practice now, if you're watching the recording, pause it now, click on those links in the chat box if you've got it open or below the video, and have a go at those before going on to the next bit. Okie dokie then, formula. Now, formula is a set of instructions for working something out. Now, it's like an equation. It's just got a lot more letter symbols in it, more variables. Now you've kind of met this guy. E equals mc squared is a formula for E. It tells you how to find E. Now E is energy, you may or may not know, and m is mass. C is the speed of light. That's a fixed number. That's actually a constant, but let's not worry about that. So this formula tells us how these physical quantities are linked, and they come up a lot in maths and physics and lots of other subjects, but it works a little bit like an equation. Yeah, C is actually the speed of light in a vacuum. Now the letter that appears on the left of the equal sign, so usually in a formula you'll just have one letter, equals, and then something with lots of other letters in it, and that's called the subject of the formula. Later on in the course we'll look at how to change the subject of the formula, but don't worry about that now. In fact, I don't think I'll go back to that until Unit 3. If you want to go on and do the lesson in Unit 3 and study it now, you can, but I'm not covering it for now. You can do it later. So in the formula, E equals mc squared, E is the subject of the formula. Now I usually say formulae for the plural, but sometimes you'll see formulas. You can use it whatever way you like, but because it's a Latin word, formulae is just what I'm used to saying. So if I'm saying formulae, you say, why is she saying that? One formula, lots of formulae, but you can say formulas. That's absolutely fine as well. And we need to substitute the values into the formula to find the thing that we're looking for. And usually they'll include units like degrees or centimetres or pounds and pence. But the thing to remember is don't put the units into the formula, just put the numbers, and you can put the unit in at the very last step. So don't put it in first. So here's an example, the very straightforward example. The area of a rectangle is given by the formula A equals WL, where W is the width and L is the length. Now normally the letters will tell you what you know, that W stands for width, L stands for length, but not always. It just depends. So sometimes they don't stand for anything. Find the area of a rectangle with width of 7 and length of 8. So the way you would work this out is you would start by writing down the formula. Always do that in the first step. So A equals WL. And then put in the numbers that you've been given. So W is 7 and L is 8. Remember that WL means W times L, or W multiplied by L. So A is equal to 7 times 8. I'll type it in the chat box. Length times width. So 7 times 8, need to know your times tables, 56. So the area is 56 centimetres squared, and we can put the units in the last step here. Now, mostly you'll be given the units in most of the GCSE maths exam papers. If you look at them, it will actually say the unit on the answer line, so you don't have to worry about thinking about what that is. Now, sometimes the value you need to find is not the subject of the formula. You can either rearrange the formula, but we're not going to worry about that because that could be complicated. But usually what will happen is you'll put in the numbers that you've been given, and then you'll just have to rearrange it after that. In other words, you're solving an equation. So you just put the numbers in that you've been given, and then you solve the equation, the resulting equation. That's usually the easiest way to do it. So let's have a look at this one. So the area A of a triangle, hopefully you've met this formula before, it's one of the ones that you need to know for GCSE maths, is given by A equals half BH. So half times the base times the height. where b is the length of the base and h is the perpendicular height. Now, if the area of the triangle is 12, and the question we're given units, but we don't need to worry about that, just make sure all the units are the same. So if the area is 12 centimeters squared and the height is 4, what is the length of the base? Some people having a try of that already. So the area is 12. So A is 12. So we need to write 12 first. So first of all, we've got the A equals half. And I'm putting all of the timeses in here just so it's clear. Times B times 4. Okay, no, oops, times 4 because 4 is H. So in place of H, let me just rub that out. So that's the formula. Area is half times the base times the height. Instead of A, I'm going to put 12 because that's that value there. So I put 12. And then instead of H, so that's the area, is 12 and the height is 4. So instead of H, I'm going to put 4 there. And then the thing I'm trying to find is this. So let's tidy this up now. So we've got 12 equals. Now here I've got half times b times 4. Now remember, when you're multiplying things, it doesn't matter what order you multiply them in. If I had 3 times 2, that would be the same as 2 times 3. So if you think of it this way, half times 4 times b, then it might be a bit easier to work out. Half of 4 is 2. So I've actually got 12 equals 2b. Do it step by step. You don't have to get the whole answer straight away. So half of 4 is 2, and then I don't need to say 2b, 2 times b, I'll just say 2b. Is that okay? And then in the next step, to solve this equation, I'm going to divide both sides by 2 to get the b on its own, like that. If I divide both sides by 2, so you can imagine, you can do it in your head. So that's divided by 2, and that's divided by 2 to get b on its own. 6 equals b. Now normally I wouldn't write 6 equals b, I would write b equals 6. So you can just swap it together at the last step like that. So b equals 6 centimeters. And then check that that works. So check that half base times height does give me 12 centimeters squared. So half times b, half of 6 is 3. And then 3 times 4 is 12. So that works. Okay, now that's a little bit complicated and might take a little bit of practice. So the first step is to substitute all the values that you've been given. That will give you an equation, and then you need to solve that equation to find the missing letter. And that's it really. So formulae often do end up becoming problems in solving equations. Now sometimes we're given some information and we need to write a formula using letters to represent each quantity. Now often these appear in geometric context, but we'll look at those later on when we've done some geometry, things like angles in a triangle, or the perimeter of a shape or something like that, or an area. So we're given the length and the width in terms of an algebraic expression, and then we need to write a formula. But we'll just keep it quite simple for now. So an example is this kind of thing. We've got a sort of a real life context. So we're told that Sally earns a basic salary of £200 a week working in an office. And then she also earns £7 an hour for every hour of overtime she does. Always look out for every. When you see for every in this kind of context, it means that there's going to be some multiplying involved. So if it's £7 for every hour, that's going to be 7 times the number of hours. And then she's got her basic salary of £200. So part A says, write down a formula in words, so we don't need to do any symbols, to work out Sally's pay in pounds. So what do we do to work out Sally's pay? Well, we start with her starting pay, her basic pay, 200. So her weekly pay equals 200 plus 7 multiplied by every hour that she works. So something like Sally's weekly pay equals 200 plus 7 multiplied by each hour of overtime. Now part B says write down a formula to work out Sally's weekly pay in pounds using P, so it gives us the letters that we need to use. P to represent weekly pay, and H to represent each hour of overtime. Okay. In the chat box, please, if you can think of it. So Sally's weekly pay, we're going to use P, so just call that P. Lisa, that looks good. And then we've got 200. And then we've got plus. And then 7 times each hour of overtime. H represents each hour of overtime, so 7 times H, we normally just write as 7H. We don't need the multiplication sign. And then once you've got that formula, you might be asked how much would she earn if she does 10 hours of overtime, and then you'll be able to work that out. You'll be able to substitute 10 into the formula and put it in place of H. 7 times 10, and then add on to 200, and that will give you the answer. Okay, there we go. And you might be asked something the other way around. You might be told in a particular week she earns this amount. How many hours of overtime did she do? In which case you'll need to put P, the value that you were given for her total pay, into the formula and then solve the resulting equation to find H. Okay, I hope you're not feeling overwhelmed by this. It will all take a lot of practice if you've not done it before, but you will get the hang of it hopefully soon. Here's another example. So the time taken to roast chicken is 1 hour plus 30 minutes for every kilogram that the chicken weighs. Now you've probably seen this on your supermarket packaging. You think, oh, how do I work that out? So you've got your fixed amount, 1 hour, and then you add on 30 minutes. Remember, always look for every. For every always implies there's going to be some multiplying at some point. So write a formula for the time it takes in hours, T. So it's going to start with T equals. To make a roast chicken weighing K kilograms. So what do we do to K? We multiply it by 30. Now the problem here is that we're writing a formula for the time it takes in hours. You have to be very careful with units. Whoops, didn't mean to cross that out. That's just my hand slipped. I'm trying to write with the mouse. So T is the time it takes in hours. So we have to be very careful because if we just wrote 30, 30 is 30 minutes. How do I write 30 minutes in hours? Any idea? How do I write 30 minutes in hours? Sidra, perfect, half. You could write it as half an hour like that, or you could write it as 0.5 hours. So it's either half an hour or 0.5, just whatever you find easiest. Half or 0. I would probably use a half, like written like that. But if you want to use 0.5, you can. So we're actually going to multiply the K, the kilograms, by half or 0.5 rather than by 30 because that would give me minutes and I want it in hours. So I have to be a little bit careful with formulae that before you write the formula, all of the units have to match so that I get the right answer. So we've got T equals 1, which is 1 hour, plus half, like that, half K. Or you could write that as K over 2 as well. So if you wanted to, it means exactly the same thing. You could write it as T equals 1 plus K divided by 2. Whoops, K divided by 2, like that. In other words, half of K, because it's half an hour. That makes sense? So, yeah, Sidra, good. Be very careful. I know what you mean, but you've written half K. I know what you mean, so don't worry. I thought maybe you were writing 1 over 2K, but I know that you don't mean that. If in doubt, write 0.5. You could also write it like this. T equals 1 plus 0.5K. Like that, 0.5. Okay. That's perfectly okay as well. Use your formula to work out how long it will take to cook a chicken weighing 1.5 kilograms. Write your answer in hours and minutes. So all we have to do now is put that number 1.5 into the formula and see what the big T value is going to be. And then we can convert the time after that. So we've got 1 plus a half of 1.5. Who knows what half of 1.5 is? Probably the easiest way to do it is do half of 15, which is 7.5, and then times by 10. So that will, yeah, we could 1 3/4. Yeah, I know. I think I know what you're doing. So, or you just use a calculator. So you could think of it like this: 1 plus 1.5 divided by 2. Half of 1.5 is 0.75 because half of 15 is 7.5. Half of 1.5 is 0.75. So it's 1 plus 0.75. Does that make sense? If you're not sure, you can use a calculator. So T is equal to 1.75. Remember that means the same as 1 3/4. So Sidra, I know you wrote that ages ago. Well done. You probably worked it out already. So what I've got is 1 3/4 hours. So what's that going to be in minutes Hours and minutes. 1 hour, that's easy enough. What's 3/4 of an hour? 1/4 of an hour is 15 minutes, so 3/4 of an hour is 45 minutes. You probably know that already, or just work out 3/4 of 60. So you could do 1.75 times 60 if you've got a calculator. I'll probably do it that way. So 1.75 times 60. The thing with maths, there's always so many different ways of working it out. I'd probably just write it as 1 hour and 45 minutes, but you can write it like this if you want. If you get 105 minutes, you need to subtract 60 though to get it into hours and minutes. So that's 1 hour and 45 minutes. Just whatever way makes most sense to you when you're looking at the question. I could do it on 2 different days and work it out in 2 different ways, but as long as you get the right answer, that's the main thing. Okay, perfect. Everyone that got 105 or 1 hour and 45 minutes, that is correct. Well done. If you want to try some quick questions now, I know you can't do that if you're watching live, but if you want to pause the video, if you're watching the recording, head over to Centre for Innovation and Mathematics Teaching. I might link you to these again. They're quite good, these worksheets. Try these 2 worksheets. I mean, some of them might involve rearranging formulae, which I know I haven't done yet. But if there's any questions that seems to be beyond what I've covered in this lesson, leave it out for now and go back to it later on. But sheet number 1 should be okay. You should be able to do most of those questions. Okay then. One last thing, just looking at the time, I've got about 15 minutes. Let's look at inequalities. They work a lot like equations, but they cover a range of values. So hopefully you've met these symbols before. Greater than, less than, greater than or equal to, less than or equal to. So normally the way you remember this, which way round does it go, is you have the big end, think of it as a crocodile's mouth or something like that. So you've got the big end on the left, the small end on the right, and that's the way it goes. So if I write x is greater than 3, that means x is greater than 3. You could read it like this, x is greater than 3, or you could read it like this, 3 is less than x. Either way. Let me do one with just letters in. So if I had a is less than b, that means, reading it this way, a is less than b. Reading it this way, it means that b is greater than a. And if you have a line like that, or horizontal line, it means or equal to. So it can be less than or equal to, or greater than or equal to. And we can show these kind of relationships on the number line. I'll show you how in a moment. So this is a is greater than 5, b is less than 0, or 0 is greater than b. Read it either way around. C is greater than or equal to 2.5. D is less than or equal to -3. Have you met those symbols before? Oh, how do we show this on the number line? So what does this mean? X is greater than 2. And what that means is x can be any number bigger than 2. So it can be 3, 4, 5, 6, 6.5, 10.53, anything bigger than 2, but it can't be less than 2. So it can't be 1 or 0 or any negative number. How do I show it on a number line? Well, just draw a number line, but infinitely many values greater than 2. So I put a circle. In this case, it can be equal to 2, so I'm going to use an open circle like this, and then an arrow like this. Like that. So it means it includes all of these values here, 2, 3, 4, 5, 6, 7, going on forever. The arrow at the end means it goes on forever, but none of the values on the other side. Okay, and that hollow circle, open circle not coloured in, means it doesn't include 2, so it can't be 2. It could be 2.1, but it can't be 2. It could be just slightly more than 2. Happy with that? All right, let's look at a few more. I know you can't really help me out with this by typing into the box, but we'll just look at these quickly. So part A, x is less than 3. So first of all, let's find 3 on the number line. It's there. X can't be equal to 3, so we just do an open circle. And it's less than, so we just draw a line like that. There we go. Let's have a check. Hooray, we got it right. Part B, x is greater than or equal to -1. Here's -1. Now it can be equal to -1, so this time we need a coloured in circle like that. And x is greater than this time, so it's bigger than -1. So this time the arrow needs to go in this direction. So we do the dot and then put in the arrow. And then my last example, x is less than or equal to 2. So we've got the little n towards the x, so this time we're going to be going in this direction with the small one. So let's find 2 first of all. There's 2. And it's or equal to, so that little line underneath means less than or equal to. So it means that the dot needs to be coloured in because it includes the number 2. And then because it's less than, our arrow is going to go in that direction. There we go. Think you can have a go at those? They're not too bad, are they? Now, sometimes inequalities can be combined in a single statement. I'll just cover that here. So you might see something like x is greater than 3 and less than or equal to 7. You just have to be a little bit careful about the way it's written. So the way it's written, this looks like 3 is less than x and x is less than or equal to 7. But the x is in the middle. So what this effectively means is that x is between 3 and 7. It's bigger than 3 and less than or equal to 7. So we combine these two inequalities. Now notice that has to be swapped round when we put the x in the middle. But what you have to be very careful of is that you never have something like this. So if you've got the x in the middle, I don't know, and the 3 and the 7, this will come up a lot in statistics and things like that when you're defining ranges. You would never have the inequality symbols going in opposite directions. It just doesn't make sense. That would mean 3 is bigger than x, and so x is both less than 3 and less than 7, which doesn't quite make sense. It's not really saying what we want it to say, and nor could you have the x in the middle with them both going that way round. That just doesn't make sense at all, because that would mean that x was bigger than 7 and also bigger than 3. So it's just not quite right. It's not saying what we want it to say. I suppose you could have it going like this. Let me just rub this out. Normally you put the smaller number first. Not normally, almost always. But I suppose it wouldn't be completely incorrect for you to have it all going the other way around and have something like 7 is greater than or equal to x, which is greater than 3. I suppose you could have it like that, but almost always these symbols will be going in this direction with the letter in the middle and the numbers either side. So if I had 2 and 10, that means x is between 2 and 10. Happy with that because x is bigger than 2 and x is less than 10. Happy with those. It'll take a little bit of practice. Even some of my A-level students get these mixed up, so please don't worry if it just is a little bit confusing at first. You'll get used to it. It will just always look like that. So after a while, you'll be able to know what looks right. And this is how you would show that particular inequality on a number line. X can't be equal to 3, but it's bigger than 3, so we put an open circle here. And then x is less than or equal to 7, so we put a closed circle there. And then it can be every value in between like that, between 3 and 7. Okay, let's try and illustrate this one on a number line. So this says if x is greater than or equal to -3, but less than 4, show this inequality on the following number line. So that's how I would read it. I would start with the x, and I'd say the x is greater than -3, reading it that way, and then the x is less than the 4. Or the x is between -3 and 4. So let's start with the -3, that's here. And it could be equal to -3. So if it can be equal to -3, I'd do a coloured in dot. And then the 4, that's over here. But because it's just strictly greater than, it hasn't got the little equal sign, it hasn't got this little line on it, then I need to do an open dot like that. And it could be any value in between those two, so then you just connect those with a straight line like that. Okay. And then part B. And sometimes you might get a question like this in the exam. It says write down all the integer values, remember what integer means, for x that satisfy, that means that solve or that work for the inequality -3, or x is greater than or equal to -3, bigger than 4. So what I'd like you to do in the answer line, if you can, is write down any of the numbers that satisfy that inequality, that make that inequality true. So can x be equal to 5? It doesn't fall in that range, so no it can't. So have a little think about it now. Integer, remember, means any whole number. So integer is just any whole number that can be positive or negative. So what we're just doing is looking for whole numbers that are between -3 and 4. So what you do is list all of the whole numbers that are between -3 and 4, including -3. The reason we include -3 is that we've got a little line there, so less than or equal to, or x is greater than or equal to. So then, and you think -3, -2, 1, 1, 2, 3. We can look at the number line to help us. So this range that we've marked in blue here includes -3, so we include that. Includes -2. Doesn't include this. This is outside the range. -1. 0 is an integer, so we include that. 1, 2, 3, but not 4, because this white circle, remember, means that it doesn't include 4 because it's less than 4, but not including 4. And it doesn't include 5, doesn't include 6. So Vernon, you were very brave, almost a perfect answer, except you missed out 0. So you've got all of those there, and you just list them like that. And if you're in the exam and you don't have a number line in front of you, just draw one, and that might help you put in every solution that you need. That's it. That's how you write that. Okay. Here's another one. Write down the inequality represented on this number line. So have a go at typing this in the chat box. Just use the greater than or equal to symbols on your keypad. If you need to write or equal to, then you can just put the equal sign as well. So this is saying that x is, so this is x. The x is between -4 and 2. Have a go at writing that, remembering what we've just covered. Make sure you get your symbols the right way around. Anyone going to be brave enough? Start with the -4. So write that first, -4. X is bigger than -4, so we just put -4, then the symbol in the right direction, and then the x, and then the symbol, and then the 2. Elia, perfect. Oh, no, sorry, almost perfect. I know what you mean. You just got the 2 and the sign the wrong way around, but very brave of you to be the first one to try to write it on it, and I'm glad you got your sound sorted out. So yes, the open circle means it doesn't include those values, so we're just using greater than. So we've got -4, and then the -4 is less than x, which is less than 2. Perfect. Angela, you got it. Bernice, and that's the solutions. Good, good, good. Okay, happy with that? Hopefully that's not too tricky. There's a very good interactive worksheet here for you to try some questions. Lots more examples. Try those out. We're not going to do solving inequalities in this session. We'll go back onto that later on. I just want you to get an idea of what an inequality is and how to show it on a number line. So it's been a bit of a quick tour of those 3 different things that we're going to meet a lot of in this course as we go through. So I just want you today to get used to the idea of equations, formulae, and inequalities, and we're going to be working with them a lot later on. So don't worry about covering everything to do with those topics, because it's really just an introduction for today. You don't need to worry about it too much for just now. On your course page, section 7 has got some exercises for you to try. So here's linear equation. I'll just give you a direct link. You know where to find them. Just log onto your course page, scroll down to section 7. There's a section on linear equations, inequalities on a number line, using formulae, and substituting into formulae. Hopefully those questions aren't too well. There might be some harder ones. Now, I think probably a lot of the content of these chapters will be too difficult for anyone who has only ever just watched this lesson at this stage. If you want to go ahead and try some of the harder examples, you can, because I've just introduced the topics for each of these chapters. So I'm just going to give you the links to the chapters in the textbook. But there's a lot of work to do on these topics, and we're going to go back to them as we go through the course later on. For this Unit 1, just want you to get used to the basics of algebra. And then next lesson I'm going to go on to coordinates. So that's just your first taste of algebra, and we'll go back to it later on. So if you want to try any of those exercises, it's chapter 14, 16 or 34 in the Foundation Tier book. If the textbook is really too hard, I've got that with me today. There's a very good book. It's quite thin, but covers everything that you need to know for Foundation Tier. And the exercises I've got, I'll show you what it looks like. I don't know if you can see on the webcam. you just write directly into this workbook. It only costs a few pounds on Amazon. So if you're finding that the textbook is a bit text heavy and a bit hard and difficult to read, don't worry about it. You can just use one of these books instead. I'm also linking you there to the Key Stage 3 book. So if you want to use that instead, you can. And these go very well with the Maths Buster. I say DVD, you don't have to buy it as a DVD, it's probably better. A lot of people don't have DVD players on their computers anymore, so you can go to CGP and get an online code to activate that. So it goes very well with Maths Buster. So if you are using Maths Buster, I've demonstrated it before in some of my other lessons. If you want to get a copy of that, it follows the same order as those CGP books. So if you want to get that, and it generates hundreds of random questions, so it's really good for getting lots and lots of practice. Next lesson, I'm going to cover coordinates and midpoints, as I mentioned. Do come along. Midpoints are kind of tricky. Coordinates should be quite straightforward, but I'll do some more difficult examples in there as well. There's a question on the first test paper at the end of this unit, test paper 1 with coordinates, that a lot of people find tricky, but I'll cover all that you need to know to answer that question next lesson. If you find the algebra that I've covered so far a bit basic and you want to move ahead and work through more quickly, I'm going to go on to solving equations and inequalities in lesson 23. So if you want to jump ahead, watch the recorded version of lesson 23. You can do that, and then you'll be able to go through a bit more quickly. I'm not holding you back. You don't have to do the lessons in the same order that I'm doing them now. If you want to move ahead, you can. No worries, Angela. I am just finished. And if you want to do rearranging formulae, which I've mentioned but not done, then you would need to skip ahead to lesson 39 in Unit 3. So that's about it from me for today. Are there any questions about today's lesson? If you need to break it up and watch it in several small sections, that's absolutely fine. If you need to watch it again, hopefully you've enjoyed it. Please do take a moment to write a short review on Trustpilot if you get a second. So just how you found this lesson and whether you found it helpful. It doesn't have to say very much. Mention my name, please. That would be much appreciated. So anyone who's watching, even if you're watching the recorded version, click on that link, leave a quick review, and that would be much appreciated. And if you've got any questions, you know where to come to get help. That's all from me for today, and I will see you next time. Bye.